Hi, and welcome to this Neverlang tutorial. In this tutorial, we will show you how to implement simple domain-specific language using Neverlang. The objective of this tutorial is to show that Neverlang makes possible to define a complete language implementation in a modular way. Each component of the language can be compiled separately and independently from the others. The Neverlang framework is built on top of the Java runtime. It fits nicely in the Java ecosystem, using the tools that are native to this platform and providing an environment that is easy and comfortable to use to the Java developer. Loglang is a simple DSL that describes tasks for a log rotating tool, similar to the logrotate Unix utility. A program written in Loglang is a list of tasks that should be performed on log files. Each task is a list of file system commands such as file removal or renaming. This is how an input file for the Loglang interpreter should look like. As you can see, each task is identified by a name, and each command is followed by one or more paths, enclosed within quotes. For instance, the backup command is followed by two string literals because the backup copy of the source file should be placed in a different destination path. On the other hand, the remove command operates only on the path of the source file. We will now show how to implement the interpreter for this script using Neverlang. Neverlang implements the syntax-directed translation technique in a modular way. In the syntax-directed translation technique, the compiler or the interpreter for language generates a parse tree for an input program, and then it visits this tree several times, attaching attributes to the nodes. Each visit is called a compilation phase. The final result is the execution of the program in the case of an interpreter, or executable code in the case of a compiler. In Neverlang, each feature is defined in a separate module. Each module contains a section that defines the syntax for the feature, and it may contain one or more role definitions. A role is the part of a compilation phase that is bound to a particular syntactic feature. Consequently, each role contains only those semantic actions that should be performed when that part of the syntax is recognized by the interpreter. Each feature is then described by a slice. A slice ties together related syntax definitions and roles, possibly coming from different modules. Finally, the language descriptor lists every slice that the language implementation requires and defines an order for the roles. Because every slice represents a feature and every role represents a phase, the language descriptor actually describes the full language implementation. The input file for the first version of our language includes the definition for a task as a list of commands and only 3 built-in commands: backup, that copies a file to a long-term storage location, rename, that moves a file, and remove, that unlinks the file. This is how the module for the backup command looks like. As you can see, the reference syntax section defines the syntax for our feature, represented as a BNF grammar. Unquoted identifiers represent non-terminals, while quoted strings are terminals. By convention, non-terminals always begin with a capital letter. There is also a way to define patterns using regular expression that we will not show here. You may have noticed that this module contains non-terminals that are not defined within this grammar. This is because they are expected to be defined in other modules. For instance, the string non-terminal should resolve to the definition for the quoted string literal that we use in the backup command. The second line here is saying that the first grammar rule describes a command. All of these missing non-terminal definitions should be resolved at the end when we will write the language descriptor. The same module may define one or more semantic roles that refer to syntax definition. In this case, we are defining a role called execution that should be executed whenever the backup command is encountered in an input file. The binding between actions and the syntax definition is made using numbers. Non-terminals are numbered from left to right and from top to bottom, starting from 0. In this case, we are hooking a semantic action to non-terminal number 0, that is, backup. Inside the action, we can refer to other logically related nodes using the same numbering scheme. In other words, we can refer to other non-terminals of the same production. Inside the action, numbers must be prefixed using the dollar symbol. The familiar dot notation can be used to set and retrieve the value of an attribute of a node. In this case, we are referring to the attribute string of non-terminal number 1 and 2, that is, string with capital S. The syntax-directed translation technique implements a sequence of visits of the same parse tree. In Neverlang, the default strategy to visit the tree is the so-called post order. That is, first the children of the tree are visited, and then the corresponding rule is executed. Even though we will not show it here, it is also possible to visit the tree in pre-order. In that case, first the rule is executed, and then the visit proceeds to the children. Because in this case we are doing post-order, then we can expect other attributes to have been set during that first visit. In this case, we expect the string attributes to be set. The double $prefixed identifier is used in Neverlang to refer a singleton instance of an object that provides some services. In this case, it is a library that provides file system manipulation primitives. The implementation for this object is defined in a separate component that is called an endemic slice. We will not show the details on how to implement an endemic slice in this tutorial, but you can find more on that in Neverlang's documentation. Modules can be compiled to source files using the NLGC tool. If you do not specify otherwise, the tool generates regular Java source files. Once these source files are generated, you can then compile them using javac. Once your modules are finalized and compiled, you will not need to recompile them anymore, because the framework is designed to be modular at the class file level. Components can be precompiled, packaged, and distributed as bytecode. It is worth noticing that the tool generates Java source files by default, but semantic actions can be written using any language supported by the Java virtual machines that compiles into bytecode. For instance, Neverlang comes bundled with support for Scala, but any JVM language that compiles into bytecode can be supported by writing a plugin using a very simple extension mechanism. If you are interested in the details, we refer you to this paper. The slice construct ties together every component that is used in the implementation of a feature. In this case, both the syntax definition and the semantic role are defined within the same module. Consequently, this is how the slice for backup looks. You may have noticed that modules defines a reference syntax, but on the other hand, slices declare a concrete syntax. In Neverlang, the syntax definition is a component like any other. Therefore, although a semantic role may refer to a particular syntax definition, the feature implementation may actually use a different concrete syntax coming from a different module. This is all specified in the slice construct. For instance, a language implementation may use English for its keywords, but then it could be possible to localize the interpreter by choosing a different, localized, concrete syntax in the slice. The first line of the slice construct always declares a concrete syntax. Every subsequent line is a role declaration. The order in which roles are executed is specified then in the language descriptor. Even slices can be compiled separately from the other components, and modules are not required to be compiled contextually to the slices that use them. The language descriptor lists every slice that the language uses and defines the order in which roles should be executed. You may notice that Neverlang.commons.simpletypes is a slice that comes bundled with Neverlang that defines common literals. In particular, it defines quoted strings that we used in the commands of our language. The slice also defines a role called terminal evaluation that we therefore execute prior to the execution role that we define in our commands. This way, we ensure that the phase that evaluates the terminals defined inside simple types will be executed before execution. Even in this case, modules and slices can be precompiled and language descriptor can be compiled separately, provided that the other class files are on the class path. The result of the compilation using NLGC is a series of simple, readable Java source files. For instance, this is how the language descriptor looks like once compiled. As you can see, the generated language descriptor is nothing but a subclass of the language class found in Neverlang.runtime package. This class can be instantiated by user code, and it provides an API to parse and execute program files. However, in order to test language implementation immediately, the Neverlang framework provides two bundled tools: the NLGI Interactive Interpreter and the NLG Launcher. The NLGI Interactive Interpreter is a valuable help to test language rapidly. It provides a series of tools to quickly verify the generated language implementation, presented as an interactive prompt. For instance, it is possible to dump the full grammar, execute programs, and inspect the resulting parse tree. The NLG Launcher is a command-line tool that requires the user to provide the canonical class name for the language implementation and the series of input files. As you can see, using NLG, we can try our new language implementation right away with the input files that we started from. As you can see, the interpreter is executing the task with the commands that were defined within. In a new iteration of the loglang interpreter, we want to introduce the merge command that was previously unavailable. In fact, if we try to execute this input file with our interpreter, we will get a syntax error. The merge command has a similar syntax to the one for the backup command, and it is really easy to implement. We can now write a new slice and a new language descriptor that includes all the new components. As you have probably noticed, the slice names that we have used in the previous version are again found in this version. This is because we're actually using the precompiled slices that composed the previous iteration. The new version of the interpreter obviously supports both the new input file and the old one. In the third version of our interpreter, we want to show off another feature that is peculiar to Neverlang. Using slices, it is possible to define in separate modules further processing phases, but again in separate components. The original precompiled units do not need to be modified. In this version of the interpreter, we want to add a permission check phase in which file permissions are checked. If the tool runs at an insufficient level of permissions, the execution of the program is aborted. Moreover, we want to add logging capabilities to the utility so that each time a task is performed, we can keep track of the operation in a transcript. In order to do this, we can define some new modules, one for each role and each feature that we want to implement. For instance, we can define backup perm check for permissions and backup logging for logging. As you may notice, the reference syntax section is shortened so that it points to the definition found in the original module. This is required to resolve the numbers in the role definitions to the correct non-terminals. You may also notice that new endemic slices are being used. The new slice for backup reflects that new roles and new modules are now involved. You will also notice that even in this case, we are still using the precompiled modules that we used in the previous iterations. The new language definition includes the endemic slices that implement the permission check operations and the logging library. In this example, we are specifying that logging should be performed before every other file-related operation. Then, we execute the permission check phase, and finally, if everything went right, we proceed with executing the task. The commented line is defining an alternate execution order. We will get back to that in a moment, but first we will compile this version of the language. In this version of the language, we will use AND to automate the build. In fact, Neverlang comes bundled with an AND task that the Neverlang developer can use to automate builds. In this case, Neverlang.nl source files are usually put in a nlg-n src directory, and generated source file go inside the src directory. Use this task with just add a test definition at the top of our build script. A typical Ant build script for Neverlang first compiles every Neverlang source file to Java source code, and then compiles all the Java source files to bytecode. This build script also generates a jar file in the dist directory. Finally, we can launch the generated interpreter with the usual command. As you can see, the output of each role has been colored so that it's easy to spot which is being executed. As we expect, first, the login role prints on the screen information about the command that is going to be executed. Then, the permission check phase in green is performed. Finally, in blue are the actual actions being executed. We want to finally show another order of execution for roles. In fact, strict sequentiality is not the only way to execute a compilation phase. For instance, we might want the execution of a role to be interleaved to another. In the interleaved execution, instead of executing one role at a time for each traversal of the tree, we execute in sequence every action that is attached to a node. In our case, previously we made the interpreter execute a full tree traversal for each of the logging, permission, and execution phases. If we use the alternate column syntax, we specify to Neverlang that we want the execution of the roles to be interleaved. So, if we uncomment the last line and comment the second last, and we then recompile the language descriptor, we obtain an interleaved execution of the phases that you can easily spot by looking at the colored lines. And this finished our short tutorial to Neverlang. We hope you enjoyed this screencast and you're going to try Neverlang soon. Thanks for watching.